This course covers sheet metal part modeling in KOMPAS-3D. We'll learn fundamental sheet modeling principles by creating a box model using the bend functionality, adding cuts and holes, and generating a drawing with a flat pattern view. In the first lesson, we'll explore what sheet metal design approaches available in KOMPAS-3D and how to adjust the sheet metal part settings. Create a new specialized sheet part document. The first difference between this document type and the part document is the number of toolbar sets. The sheet modeling document doesn't have the wireframe and surfaces toolbar set, and the sheet modeling toolbar set is primary and active by default here. You can change the document specialization at any time. In the File menu, find Specialization and click Part. Let's return to Sheet Part. Also, special variables are created automatically in the sheet modeling document. We'll discuss them later. KOMPAS-3D allows you to create sheet metal parts by bending. You need to use commands from the sheet modeling toolbar set. Notice that using solid modeling commands may limit or disable sheet metal functionality. First, let's go to the model properties. Specify the designation and name. Confirm. Save the document. You can create a sheet metal part in 3 ways. A lot of things depend on a base sketch. Let's create a sketch on the ZY plane. If you create a closed contour, and start the Sheet Solid command, extrusion will be performed normal to the sketch plane by the sheet thickness, and you will get a flat sheet limited by the contour. This is useful when you need to create a sheet of a complex shape. If you make an open contour, like this one, extrusion will also be produced normal to the sketch plane, but by the distance defined in the parameters toolbar, and the thickness will be extruded parallel to the sketch. In this case, the sketch lines define positions of the part bends. In the third case, you create a closed contour and start the shell ring command. This command breaks a closed contour at a point that you can define in the command settings. The extrusion is performed here, like for an open contour. We'll use the second way and create an open sketch. Let me rotate the sketch. Our part is symmetrical, so it would be a good idea to create a sketch that is symmetrical about the origin. Start the AutoLine command and create 2 segments to the left of the origin and similar segments to the right. Assign the equality constraint. Add dimensions. First, the overall horizontal dimension is 150. If we examine the box, we'll see that the box has varying heights in different sections. We'll use the maximum value and later remove the excess material. Start the Sheet Solid command. Specify the distance as 100. The bend radius for the box should be 1. Here it's 5 by default. We can modify it directly in this field, but the default will be 5 for each new bend. You will need to adjust the radius individually. The next important parameter is thickness. In our case, the default value is OK, so leave it unchanged. Note that it's important to specify the thickness direction when using a sheet modeling command for the first time. Let's rotate the model to better observe the result. Here everything is OK. If we change the default direction, we'll get an error in the overall dimensions of the box. You can see that the thickness exceeds the limits defined in the sketch. We need to revert the direction. Don't forget to check this parameter. Confirm and stop the command. Take a look at the bend radius. We can check it using the object info command. Its radius is 2 mm as we specified, and we need this bend radius value for all bends in our model. However, if you create a new bend, you'll see that the default radius will be 5. To save time and avoid repeated edits, you can set this value for the model. Go to the Variables panel. Here you'll find the sheet model variables automatically created when you start a sheet part document. If you create a part document, the sheet model variables are generated right after executing the first sheet modeling command. Let's change the radius to 1. If you try to add a bend now, the radius will default to 1. Let me confirm the command. If you need this value for all your models and you don't want to correct it each time, you can create a new sheet model document, adjust its parameters, and save it as a template. In the future, you can use this template to create new documents. Please note that if you try to change the value of the bend radius variable and rebuild the model, not all the radii will be updated. The radius values defined in the parameters panel remain unchanged. The link between the radius and its variable was broken when we assigned a specific value. However, if the link for a particular bend wasn't disrupted, its radius will adjust accordingly. To restore the link, enter the variable name either in the radius field in the parameters panel or in the appropriate field in the variables panel. You'll see that this variable name is assigned for the bend. Press F5 to rebuild. Now all the radii have been changed. If you need different radius values for bends, use the parameters panel. Let's return 1 and rebuild. Now you know that KOMPAS-3D provides several approaches to sheet metal design. We have adjusted the settings for a new sheet metal part and created its base elements.